Hello, welcome again. This is the sigma notation part 5. This video in fact consists of two problems. Find a formula for the sum of n terms. Use the formula to find the limit as n approaches infinity. Limit as n approaches infinity to sigma from I equal 1 to n 13i over 2n squared. First of all, we should ask ourselves a question. Sigma from I equal 1 to n. This means that 13 is constant and the 2 is constant. N squared is constant with respect to this sigma, because sigma has only one variable, which is I. So we can write it this way. Limit as n approaches infinity, 13 over 2n squared sigma I from I equal 1 up to n. The only variable here is I, which equals to limit as n approaches infinity, 13 over 2n squared. What is the sigma of I? Sigma I is n into n plus 1 all over 2. This is sigma I. Now, I think that we can simplify this writing. The expression becomes 13 limit n approaches infinity, 13 over, let's multiply this 2 by this 2, so the result is 4, and leave everything n inside. So n times n is n squared, plus n times 1 is n over this n squared should be written here, n squared. Now, if I want to reduce this or find this limit as n approaches infinity, all we have to do, like any other rational function, we should divide by n to the highest power up and down. So let me divide this term by n squared and this term by n squared. So the result equal limit as n approaches infinity of 13 over 4, 1 plus dividing n by n squared gives us 1 over n, and down we have 1. This 13 over 4 could be taken outside the limit as it is constant. So again we have 13 over 4 limit as n approaches infinity of 1 plus 1 over n all over 1 equals 13 over 4. The limit when n approaches infinity of this term 1 over n will be 0. This term becomes 0. So everything else is 1. It's multiplied by 1 over 1, which is 13 over 4. This is our last solution. Done. Let's go to the second part. In this case, we want to find the limit of the sigma, limit of the sum, as n approaches infinity also. 5 plus I over n into 2 over n. This problem may be a little bit longer, but we will apply the same idea. With respect to the limit, a limit depends on infinity. Limit depends on n. We can do nothing with respect to it. But with respect to the sigma, the only variable is I. So we can take everything else outside. Can we apply this inside this long bracket? No, we can't, because this is sum. Sigma sum equals sum of sigmas. Sigma sum equals sum of sigmas. So this becomes sigma 5 plus sigma I over n. But sigma product, we can take the constant outside the sigma. This is rule number 1. So if I want to find this, first of all, I rewrite the problem. Limit as n approaches infinity. And we will take this part, this constant, I will take it outside the sigma, but not outside the limit. So it will be 2 over n here into sigma from I equal 1 to n 5 plus I over n. This sigma could be written as sigma of 5 from I equal 1 to n plus sigma of I over n as I change it from the value 1 to n. And this result is multiplied by a constant, which is 2 over n. So we can write our solution as limit as n approaches infinity, 2 over n. Do you remember what is the sigma of 5 from I equal 1 to n? 5 is a constant. So just multiply 5 by n. So it will be 5n. I want to show you something also. What about this sigma I over n? N is constant. We can take it outside. So this part could be written as 1 over n sigma I from I equal 1 to n. Again, we found this sum. Plus, I will write instead of this expression that one, which is 1 over n. Now, what is the sigma of I? It is n into n plus 1 all over 2. Now I have a question. Can we reduce this n with that n? Yes, but we can't reduce this n with this n, the inner one, because this is sum. But I can reduce this n with that n. Now, let's rewrite it once more. It will be limit as n approaches infinity of 2 over n into 5n plus 1 times n plus 1 is n plus 1, and down we have only 2. So it remains to rewrite before we find the limit. This equals limit as n approaches infinity. 2 over n is multiplied by 5 over n. So this means 10, because n will be cancelled, plus, if I multiply 2 over n into n plus 1 over 2, the result is going to be 2 n plus 1 over 2 n. Again, we can cancel the 2's. So if we rewrite it once more, it will be limit as n approaches infinity of 10 plus n plus 1 over n. What is the limit as n approaches infinity? This equals to 10 plus 1. So the final result is just 11. Why is that? Because this limit, since powers, highest power of n up and down are the same, so we take coefficient over coefficient, which is 1. So everything here is 1 plus 10, which is 11. Thank you. See you next video.